There's a liquid that costs $3 at any hardware store. One single coat on bare concrete and water never penetrates that surface again. Not for a season, not for a few years. Never again. No epoxy, no professional sealer, no $400 contractor visit, no specialized spray equipment, no second coat required. Roman engineers applied it to aqueduct tunnels in 100 AD, and those tunnels still hold water today, 2,000 years later, without a single reapplication. Medieval castle builders brushed it onto dungeon floors before winter floods, and the stone beneath never crumbled. Construction crews building the Panama Canal used it on concrete lock walls in 1913, and engineers inspecting those same walls in 2019 found zero moisture penetration, over a century of waterproofing, from a single treatment that cost pennies per gallon. The global construction waterproofing industry generates over $60 billion every year. Basement sealing services charge between $800 and $3,000 per job. Concrete waterproofing contractors operate franchises in every major city in America. Every single one of them knows exactly what you're about to learn. They did not stop recommending this liquid because it failed. They stopped talking about it because it worked too well. A $3 solution that permanently waterproofs any concrete surface is not a business opportunity. It is a $60 billion extinction event. This is the story of sodium silicate, the concrete treatment that built empires, saved armies, and that the construction industry has spent 80 years hoping you never find in the hardware store aisle. This is where we crack open the vaults they welded shut. Now let me take you back to where this all begins. The year is roughly 100 AD. The Roman Empire is at the peak of its engineering ambition. Across 3 continents, Roman architects are building aqueducts, massive stone and concrete channels that carry fresh water hundreds of miles from mountain springs into the heart of every major city. The engineering problem they face is enormous. Concrete absorbs water. Stone fractures under freeze and thaw cycles. An aqueduct that leaks is an aqueduct that fails. And a failed water supply means a city dies. Roman engineers discovered something that changed everything. When they mixed a specific mineral compound into their mortar, a compound derived from volcanic ash found near the town of Pozzuoli on the Bay of Naples, something remarkable happened at the molecular level. The compound reacted with calcium hydroxide inside the concrete and formed an entirely new crystalline structure. That structure filled every microscopic pore in the material. It did not coat the surface. It became the surface. And once formed, that crystalline matrix was completely impervious to water. The Romans called the volcanic ash pozzolana. Modern chemists call the reactive compound amorphous silicon dioxide. You can buy the refined version at any hardware store today for $3 a quart. It goes by the name sodium silicate, or in some product lines, water glass. The chemistry has not changed in 2,000 years. Roman aqueducts, treated with pozzolanic compounds, survived earthquakes, barbarian invasions, volcanic eruptions, and the complete collapse of the civilization that built them. The Pont du Gard aqueduct in southern France still stands today after 2 millennia of rain, frost, and flooding. Engineers who have analyzed its concrete structure found the pozzolanic waterproofing reaction still chemically active inside the stone, still blocking moisture at the molecular level, after 2,000 years of continuous exposure to weather. But Rome was not alone in this discovery. By the 7th century, Persian engineers constructing the massive Connaught underground irrigation systems in the Iranian plateau were applying silicon-rich mineral slurries to stone channel walls before diverting water flow. Persian engineering manuscripts preserved in the Iranian National Library describe the process in precise detail. Mix the mineral with water, apply to stone, wait 3 days, then introduce water flow. The channels treated this way lasted centuries without resealing. In China, architects building the water features of the Forbidden City in the 15th century mixed slaked lime with rice water and volcanic mineral pastes to waterproof the ornamental pools and channels. Those pools, still filled with water today, have never been relined. The original waterproofing treatment applied 600 years ago is still holding. In colonial America, engineers building the Erie Canal in 1817 faced the identical problem that confronted Roman engineers 1,500 years earlier. They needed a waterproof concrete that could withstand constant immersion, freeze and thaw cycles, and the mechanical stress of barge traffic. They found the answer in natural cement made from limestone deposits near Chittenango, New York, which happened to be naturally rich in silicon compounds. The Erie Canal lock walls built with this material in 1825 were still structurally sound and watertight when engineers inspected them in 1995, 170 years after construction. Every civilization that built with stone and water arrived at the same solution independently. That is not coincidence. That is fundamental chemistry that does not change regardless of the century, the continent, or the culture making the discovery. Now, let me show you exactly why this works at the molecular level. Because the science is what makes the construction industry genuinely uncomfortable about this video. Concrete is not solid. Under a microscope, concrete looks more like a sponge than a rock. It is riddled with millions of tiny capillary pores, channels and voids left behind as water evaporates during the curing process. Those pores are the enemy. Water enters through them carrying dissolved salts, chlorides, and carbonates. Inside the concrete, those minerals crystallize as the water evaporates. The crystals expand. The concrete cracks. The cracks grow wider. More water enters. The cycle accelerates. This is why concrete deteriorates. This is why basement walls leak. This is why garage floors stain and pit. This is why bridge columns crumble. Not because concrete is weak, because concrete is porous. Sodium silicate, the $3 liquid, solves this problem at its source. When you apply sodium silicate solution to concrete, it does not sit on top like a paint or a wax coating. It soaks directly into those capillary pores through the same surface tension mechanism that pulls water into dry soil. It penetrates up to 4 inches into dense concrete and up to 6 inches into more porous mixes. Once inside, a chemical reaction begins. The sodium silicate, which is chemically silicon dioxide bonded with sodium oxide, reacts with the calcium hydroxide that is always present in concrete as a byproduct of cement hydration. That reaction produces calcium silicate hydrate crystals, the exact same crystalline compound that gives concrete its structural strength in the first place. Those new crystals grow outward from the pore walls until every channel, every void, every microscopic gap inside the concrete is completely filled. The concrete does not just become waterproof, it becomes denser, harder, and stronger than it was before treatment. A study published in the journal Construction and Building Materials found that concrete treated with sodium silicate showed a 31% increase in compressive strength after 7 days of curing, 31% stronger from a $3 treatment. A research team at the University of Texas at Austin tested sodium silicate treated concrete specimens against untreated controls in a freeze-thaw cycling chamber, the same test used to simulate 20 years of outdoor weather exposure in northern climates. The untreated specimens showed significant cracking and surface deterioration after 300 freeze-thaw cycles. The sodium silicate treated specimens showed 0 surface deterioration at the same cycle count. 0. The treatment did not slow the deterioration. It stopped it completely. And here is the part that should make every waterproofing contractor in America put down their pricing sheet. The crystalline matrix formed by the sodium silicate reaction is not a temporary barrier. It does not wear away. It does not peel, flake, or degrade with traffic. It does not break down under UV exposure or freeze-thaw cycling. It is a permanent structural component of the concrete itself. The concrete was porous. Now it is not, and it will not be again. Not from weather, not from salt, not from time. The chemistry does not wear off because it is not sitting on the surface. The concrete has been chemically converted from the inside out. Now here is where the story takes the turn that the construction industry is counting on you never hearing. In 1943, the United States Army Corps of Engineers published an internal technical manual on concrete preservation methods for military infrastructure. The manual documented sodium silicate as the single most effective concrete waterproofing compound tested across field conditions in 3 climate zones: tropical Pacific Islands, North African desert, and Northern European wet cold. The results were documented in Army Technical Manual TM 5-618. It was declassified in 1959 and it is available in the National Archives today. The compound outperformed every synthetic coating tested. It cost a fraction of the alternatives. It required no special equipment, no trained applicators, and no repeat application. The Army used it on bunker floors, ammunition storage facilities, fuel depot foundations, and airstrip concrete across multiple theaters of war. After 1945, the construction chemicals industry had a serious problem on its hands. Companies that had invested millions during the war years developing petroleum-based waterproofing membranes, synthetic polymer sealers, and crystalline admixture systems now faced peacetime commercial markets. Their entire product lineup cost between 15 and 200 times more than sodium silicate per square foot of coverage. They had built sales teams, distribution networks, and contractor training programs around products that generated significant recurring revenue. A $3 mineral compound that any homeowner could brush onto a basement floor in 40 minutes was not competition. It was a business model catastrophe. So the industry did what industries always do when a simple, cheap solution threatens complex, expensive revenue. They reframed the problem. Beginning in the early 1950s, the concrete coatings industry began systematically promoting the idea that concrete waterproofing was a complex, technical, specialized service requiring professional training, certified applicators, and proprietary formulations. Trade associations published guidelines recommending against homeowner application of any concrete treatment. Contractor licensing programs created credentials and certifications that positioned professional waterproofing services as the only responsible option for homeowners. The message was never stated directly. It did not need to be. It was woven into every product label, every contractor training manual, every hardware store display. Waterproofing concrete is complicated. You need a professional. You need our products. Today, the global concrete waterproofing market is worth over $60 billion annually. The United States market alone generates over $9 billion per year. Basement waterproofing companies like Basement Systems, Terra Firma, and regional franchises operating under the Be Dry and WaterGuard brands charge between $800 and $12,000 per basement, depending on size, severity of moisture intrusion, and how effectively their sales representative can convince the homeowner that the problem is irreversibly serious. Here is what those contractors actually apply in the majority of residential waterproofing jobs: crystalline waterproofing compounds. The primary active ingredient in crystalline waterproofing technology is silica, the same reactive silicon dioxide compound that forms the basis of sodium silicate chemistry. Pull up the safety data sheet for Zypex concentrate, one of the most widely specified crystalline waterproofing products in commercial construction. The primary reactive ingredient listed is reactive silica. Pull up the data sheet for Crichton Kim, another major brand. Reactive silica, Sika crystalline, reactive silica. They take the same fundamental chemistry that costs $3 a quart at any hardware store, process it into a proprietary powder blend with cement carrier material, put it in a bag with a logo and an application specification sheet, and sell it for $40 to $90 per kilogram to contractors who mark it up another 40% before billing the homeowner. The chemistry inside that $40 product bag is performing the exact same molecular reaction that sodium silicate performs on concrete. The crystalline growth is the same, the pore filling mechanism is the same, the end result is chemically identical. The difference is the label, the markup, and the carefully constructed myth that this chemistry is too complex for a homeowner to apply. That myth is worth $60 billion a year, and it depends entirely on you never walking down the masonry aisle at your hardware store and reading the ingredients label on the $3 bottle sitting right there on the shelf. Here is exactly what to do. And it is almost offensively simple. Go to any hardware store, Home Depot, Lowe's, Ace Hardware, True Value, and walk to the masonry and concrete aisle. Look for sodium silicate solution. It may be labeled as concrete densifier, concrete hardener, silicate sealer, or water glass solution. A quart container costs between $2 and $4. That quart covers between 200 and 400 square feet of concrete surface, depending on porosity. 1 quart of sodium silicate solution covers the average American basement floor, 1,000 square feet, for roughly $8 to $12 total in materials. Compare that to the average basement waterproofing contractor, quote, $4,000 to $8,000 for interior waterproofing systems covering the same floor area. Here is the application process, step by step. Step 1, clean the concrete surface thoroughly. Sweep away all loose dirt, dust, and debris. If there is existing paint, efflorescence, the white mineral deposits you see on basement walls, or oil contamination, clean it with a solution of trisodium phosphate and water, then rinse completely. The sodium silicate needs to penetrate the concrete pores. Anything blocking those pores reduces penetration depth and effectiveness. Step 2, check for standing water or active leaks. If water is actively coming through the concrete right now, address the source before applying sodium silicate. The treatment waterproofs concrete from within. It does not stop active hydraulic pressure from an external source on its own. Step 3, wet the concrete surface lightly with clean water before applying the sodium silicate. A damp concrete surface allows the silicate solution to spread more evenly and slows surface evaporation, giving the compound more time to penetrate before it begins reacting. Step 4. Apply the sodium silicate solution generously using a cheap pump garden sprayer, a paint roller with a thick nap, or a wide paintbrush. Work in sections of about 50 square feet so the liquid does not dry before you can spread it evenly. The solution should appear wet and glossy on the surface. If it soaks in immediately and the surface goes dry within 30 seconds, the concrete is highly porous. Apply a second coat of this first application before moving to the next section. Step 5. Keep the surface wet for at least 30 minutes after application. If you are working outdoors in direct sunlight or in a warm, dry basement, reapply solution as needed to keep the surface visibly wet. The chemical reaction between sodium silicate and calcium hydroxide requires moisture to proceed. Drying too quickly stops the reaction before full pore penetration occurs. Step 6. Do not rinse the surface after application. Allow the solution to cure completely for a minimum of 24 hours at room temperature before allowing foot traffic. For vehicle traffic on garage floors, allow 72 hours of cure time. A white powdery residue may appear on the surface during curing. That is completely normal. It is unreacted sodium compound migrating to the surface as the silicate penetrates inward. Simply sweep or brush it away after the cure period. It does not affect the waterproofing performance. For basement walls showing moisture intrusion, apply the same process to the interior wall surface. The sodium silicate will penetrate the concrete block or poured concrete wall and begin filling pores from the interior face inward. For walls with significant moisture history, apply 2 full coats 24 hours apart. A retired civil engineer in rural Pennsylvania documented his sodium silicate application on a 1962 poured concrete basement that had shown water intrusion every spring for 30 years. He applied 2 coats using a garden sprayer over a single weekend. Total material cost was $11.40. He posted a follow-up 3 years later reporting 0 moisture intrusion through 3 consecutive spring thaw seasons, including 2 seasons with above-average rainfall. $11.40, 3 dry springs, after 30 years of annual flooding. The chemistry is not magic, it is not new, it is not experimental. It is 2,000-year-old Roman engineering that you can apply yourself on a Saturday afternoon. Roman engineers standing beside stone-mixing channels in Pozzuoli Harbor 2,000 years ago understood something that your basement waterproofing contractor is counting on you never learning. Concrete has pores. Silicon dioxide fills pores. Water cannot enter what has no opening. Persian engineers digging Qanat tunnels through desert bedrock in the 7th century understood it. Chinese architects waterproofing the imperial gardens of the Forbidden City in the 15th century understood it. American engineers building the locks of the Erie Canal in the 1820s understood it. The United States Army Corps of Engineers documented it in a declassified wartime manual in 1943. Your grandfather understood it. He kept a bottle of water glass on the shelf in his garage, right next to the linseed oil and the lye soap. He brushed it onto concrete, brick, and stone without a contractor quote, or a 10-year warranty certificate, or a financing plan. Then, one generation stopped passing it down, because a television commercial said there was a better way. Because a contractor in a company truck with a logo on the door said the problem was more complicated than it looked. Because a $60 billion industry built its entire revenue model on the assumption that you would never walk down the masonry aisle and read the label on the $3 bottle. That bottle has been sitting on the same shelf for 70 years. Nobody in a suit ever moved it. They just made sure nobody told you it was there. $60 billion a year depends on you standing in your wet basement this spring, believing that the only solution costs $4,000 and requires a professional with a warranty and a payment plan. It does not. It never did. It costs $3 and it takes a Saturday morning, and it has been working since before the Roman Empire fell. Now you know. And that knowledge does not belong to any industry. It never did. It belongs to anyone who's willing to walk down the right aisle and read a label. If this vault opens something for you today, subscribe to Dr. Nick Survival and share this video right now. Every single share puts a $3 solution in the hands of someone who is about to write a $4,000 check. Every subscription keeps this channel digging deeper into the vaults the construction industry thought were sealed forever. The next vault opens soon, and what is inside is the one material your great-grandfather used to seal every window and door in his house against cold air permanently, for less than the cost of a cup of coffee. The weatherization industry earns $20 billion a year, hoping you forgot his name for it.